I think the screen is visible. Screen is visible or not? Abhishek, Pratap, screen is
Yes, ma'am.
visible?
Yes. Yes, ma'am.
Yes. So if you take, so far we discussed stack and queue. So if you take some questions, what is data structure means, you should be in a position to answer. Any user-defined data structures like arrays, linked list, queue. What do you mean by non-linear data structure? Give an example. Non-linear means graph and trees. Structures will come under non-linear because they are not taking continuous or homogeneous memory locations. What do you mean by linear data structure? Give an example. The linear data structure takes continuous memory locations. Stack, queue, linked list, they will come under that category. List the various operations that can be performed on any data structure. First we have to create the, even if it is stack, queue, or linked list to trees or graph, we have to first create, then we can perform the operations like in adding, deleting, searching, sorting, reversing. What is abstract data type? What are all the, which is not abstract data type? So the data types which are following the abstraction, data hiding, and data encapsulation, that will come under abstract data type. List out the areas in which data structures are applied extensively. So in operating system, you know very well, C programming language is an system software as well as application software. What do you mean by system software? See here, no power supply, heavily raining. I'm sitting in the academic block. So the class will be another, we'll have another 10 minutes class, then we will close. All of you join. Those who are present, they will alone get the attendance. Others, I will not give attendance. So what is system software? One of you? What is system software? What is application software? Which are all the programming languages will come under system programming language? What is system software? Can you give some example? See, one of you answer. The programming languages which are used to create the operating systems, creating new operating systems like we have the operating system like DOS, Windows, Macintosh, iOS, Android, and microcontrollers. So those operating systems, compilers, interpreters, they are also created by using C programming language or C++ programming language or Python programming language. So the languages, computer languages which are used to create other programming languages or operating systems or device drivers are called system software. And the compilers also, say the C++ compiler is written by using C compiler. The Python compiler is Python compiler or interpreter. Python works using compiler or interpreter.
Interpreter.
Okay.
Interpreter.
It is written by using which language? Python interpreter is written or created using C++. Okay, so the compilers, everybody maybe normal programming languages or VC++, C hash, so many languages we have, so many Java, JavaScript, React, JS, so many tools, APIs, um, library files, so many reports, reporting tools. Everything is created by using C, C++, or Python. The programming languages are core. Using that only, we can create other programming languages as well as we can create application tools, packages, device drivers, compilers, interpreters, operating system, DBMS, database management system tools, and other numerical analytics packages like SPSS, NS2, graphical tools, animations, Unity, all those things, and AI tools, AI components, animations, everything is done by using C, C++, and Python only. That is the core. Okay, previously also we had other languages like Fortran Basic, COBOL. That is not used. Once object orientation started was come into picture, all the tools initially they will develop the new languages and tools packages using C, or they may try with directly C++ also. C++ is widely used because if you want to go with compilers, C++ is the best. Or we can go with Java also. But most of the device drivers, operating systems, system software, new programming languages, they are created using C++. What is then already we completed stack and queue. Now we are going to discuss about linked list. What is linked list means? Yesterday in class we just saw what is linked list. If you take in linked list we have singly linked list, doubly linked list, circularly linked list. Like that we have different types. So that today we will discuss all those things. Linked list. So any doubt with respect to stack and queue? Stack and queue implementation. Today we are going to start with linked list. If you have any doubt in stack and queue, ask me. Okay. Today we are going to discuss what is linked list. So linked list which provides an alternative to an array based sequence. So in a array means the array starts from zero, continuous memory, homogeneous memory locations will be allotted. The based on the size of the array, all the numbers in the list array will be stored in a continuous form. So linked list which provides an alternative to array based sequence such as an array provides more centralized representation with one large chunk of memory capable of accommodating references to many elements. A linked list relies on more distributed representation in which a lightweight object known as node is allowed for each element. Each node maintains a reference to its element, and one or more references to neighboring nodes is in order to collectively represent the linear order of the sequence. The first point is linked list is following distributed. So distributed means we need not store all the linked list elements in the same continuous memory location. We can store the elements anywhere. And it is a lightweight object known as node. So in linked list we are using nodes. Also is allocated for each and every element. Each node maintains a reference. So each node is having a reference to its element and more reference to the neighborhood elements. So it will have the node for data as well as a node for reference to the neighboring nodes in order to collectively represent the linear order of the sequence. So the each node is maintaining the address of the previous node or the successive node that points to the next element in the list. So within the linked list, we have different types: singularly linked list, doubly linked list, and circular linked list, like that. If you take what is singly linked list means, a singly linked list is a collection of nodes that collectively form a linear sequence. Okay, each node stores a reference to an object. That is an element of the sequence and a reference to the next node in the list. Say for example, a linked list, each and every node will have this is the linked list. So there is two memory locations allotted for each node. The first one is where we are going to store the element, and the next component is it will have the address of next node in the list. So a single list linked list node representation. Okay, a single node will look like this. Say for example, if you take the train, we have compartments, now coaches, coach number A1, B1, like that. So in B1, we'll have the connection to the B2, and we will have the connection to A2 also. So the previous compartment, we can, if you get into any one of the compartment, we can walk inside the compartments to reach the previous compartment or the next compartment. So like that, in node representation, we are taking each node is having memory space for storing the value, memory space for storing the address of the next node. Yeah, connectivity will be there. You can see in the train also there is some connectivity, some gap will be there, like that a junction will be there. Say for example, if you take a linked list, this is a linked list. Yeah, it is a singly linked list. Why? Because this is the first node. The first node is called the header node, and the last node is called the tail node. Okay, the linked list starts with the head node and it ends with the tail node. In each node, this is one node, head node. Each head node is having the memory location for storing the value and address location. That address location points to the next node, head node, next node to the head node, or we can say node 1, node 2, node 3, node 4. So there are four nodes in the linked list. The first node is called head node. The last node in the linked list is called tail node, and all the nodes are connected with each other. And how they are connected means the first node is having the address of the next node. Say this particular node is stored in the memory location 1000, and the second node is stored somewhere in the 2000. So the 2000 will be 2000 H address, it will be stored in this memory location. So this will point the next node. The second node is having its own value, and this second node is pointing to the next node in the linked list. The address of the next node, this may be 3000 or it may be 1500. So the 1500 address will be stored here, and the last node is called end of the node. So in each node we are storing some value. The value may be in numerical values or string values or text values. So it may be A1, A2, B1, B2, or it may be 10, 20, 30, or it may be 55, 1, 2, 6. Any value we can store. In integer, we have integer array, string array, character array, double array. The same way, the linked list, the data can be stored. The train also, we have passenger trains, what is that, cargo trains, goods trains, super fast trains. So we have different types of trains now. The same way, within the train, we can store any value. It may carry the passenger, or it may carry the goods, or it may carry the petrol, anything. So this is the singly linked list representation. So in a linked list, we have node. No, if it is singly linked list, it will have the one address alone. It will have the address of the next node alone. It will not have the reverse address. Okay. So the node for memory location for storing the value and memory location for storing the address. So what are all the operations we can perform with the singly linked list means we can insert element into the singly linked list. We can delete an element. We can rearrange the elements, or we can reverse the elements. All the operations: creation, insertion, deletion, ordering, sorting, searching, reversing, everything same as the various operations we can perform. So we need to write the corresponding code. Say for example, we have a linked list. So here the linked list, initially the linked list is created with one head node or tail node, and the head node is called having the value as 7, and it is pointing to the second element in the node 5. The address is pointing the next node, the second node is pointing the third node, and if it is tail node, it is the last node. So the address position in the tail node will be null. So it means it is end of the linked list. Okay, no more the connection. So in this case, we want to add a new node. That new node, we want to add it before the head node. So we want to make the new node as the head node and the head node as the first node. So in that case, we are creating a node with the value 4, and the address we are taking In the address location, we are storing the address of the head node. Say the head node is in the memory location called 1000. So the 1000 if you store here, and this will point the head node, and the head node will point the next node. So insert an element into the head of the single linked list, create a new node in instance storing reference to the element E, set new nodes next to reference to the old head node, set variable head reference to the new node, increment the node count. Initially the node was only 3, now the node count become 4. So we are creating a node, that node we are adding. After insertion, the newly added node 4 become head node. Previously this is head node. Now head node is marked as 4, and this becomes second node, third node, and the tail node we have the null address here. Any doubt in the logic? If you see the corresponding linked list program, so today we will discuss only single linked list. So as we discussed, if you take the list, list is an abstract data type. A linked list is a data structure consisting of a group of nodes which together represent a sequence. Each node is composed of data path, data node, and a reference point. In other words, a link to the next node in the sequence. Okay. So we are taking the node 1, node 2, node 3 as we discussed in the theory part. So the node 1 value is 5 and the address of the node 1 is 1000. And we are taking this node 2. The node 2 is stored in the memory location 2000H. H is hexadecimal memory location. Usually the memory address will be represented in hexadecimal. 1000H, 2000H, 1000H, 1002H, 1004H if it is integer. It's because we are storing an integer value. For this particular integer value, 2 bytes will be allotted. Okay, the node 1 is stored in the 1000H, node 2 is in 2000H, node 3 is in the 3000H. So here we are not allocating continuous memory location. The first node is in some place, second node is somewhere else, third node is somewhere else. In between first node and second node, there are more than 998 bytes. So the value is 583. So they are all integers. For each integer, only 2 bytes will be allotted for storing the memory address. Another, because it is an hexadecimal number, it is a long integer. Another 4 bytes will be allotted for this particular node. 2 bytes because it is of integer type. 2 bytes for integer and 4 bytes for storing the address. So total 6 bytes will be given for node 1. So in the node, we have data value and address value. Both together is called node. Okay, so the node is stored in the value position and address location, we are storing the address. The first node, this is first node. The second node is this. The second node is in the memory location 2000. So the 2000 is mentioned here. The third node is in memory location 3000. So the 3000 is mentioned here. Because this node is the last node. So we are mentioning 0. End of the node, head node and tail node. Okay, this is the memory address. The linked list is a collection of elements called nodes, each node of which stores 2 items of information. Okay, what are all the 2 items of information means a data path and a link path. Okay, The data part of each node consists of the data record of the entry. The link field points is a pointer that points the contains the address of the next node. So any doubt in the basic concept of what is linked list in the representation? Any doubt? The beginning of the linked list is stored in the pointer termed as the head node. Okay, the head node is the first node in any linked list, which points to the first node. The head pointer will be passed as a parameter to the method to perform the operation. So the header address will be shared to start the operation. The first node contains pointer to the second node. The first node contains the pointer to the second node, and the second node contains the pointer to the third node, and so on. The last node in the linked list is the next field. The address field we will store the last node. Tail node will store the value as null to mark the it is the end of the list. There are several variants of the linked list. So the various types of linked list is singly linked list, circularly linked list, doubly linked list, doubly circularly linked list. So these are all the different types of linked list we are using. Any doubt in the basic idea? You understood what is singly linked list, how it is represented, what are all the, say in stack and queue we are using different terms. Stack we have only top, push and pop. In queue we are using front and rear, add and delete. Front and rear, first in first out. We will add through the rear, we will delete through the front. If you take the linked list, it is a different representation where nodes will be taken. Each node is having data value and address value. And here we are using head node, tail node. Head node points to the first node. First node points to the second node. The last node is called the tail node. The tail node takes the address as null. So if the address is null, it means it is the last node. If you take the singly linked list, a singly linked list is a collection of nodes. Each node contains two fields: information field where the information is stored and the link field where the value is stored. So the node in linked list look like this. A node will have the information or data field, link or next field. Any doubt in this? So the operations that can be performed on a singly linked list includes insertion of nodes, deletion of nodes, and traveling the nodes in the list. The various operations on a singly linked list are insert a node into the list, deleting the nodes from the list, travel the list of elements in the linked list. Say we are taking to implement a singly linked list, we using the abstract data type using C++. We are taking the program. Okay, so ash include std lib. So we are including the library files iostream.h, conivo.h for console input output operations, input output stream operations for storing the data and stream operations. So we are creating a class called node. Okay, the class starts here and the class ends here. So a node class is created. The node will have the data field as well as pointer field to it is having the address of the next node. And we are creating a class called list. Okay. So the list class, we have two variables for private variables by default, item and address. And we have the public functions list, that is class name is list and the function name is also list. It is a constructor function. And insert in the front, inserting the element in the front, it means the header before the header, inserting the element in the end, deleting the element from the front, deleting the element at the end, displaying all the elements in the list, and counting the number of nodes in the list, deleting a node with respect to the position, delete the second node or delete the fifth node, like that, and delete after the position. Delete the element. Say if you are giving delete the node 5, not the 5, the next node. Delete after the position. So these are all the functions we are going to perform using the list class. Okay, so all the functions are declared inside the class, defined outside the class. So the constructor list, okay, class name list, function name list. So the constructor is defined. So using the constructor, so when you create an object L1 from the class list, so constructor will be the default user defined constructor will be called. In that case, say within the constructor, we need to initialize memory space for each and every node, and we have to assign the initial value. Creating a node, the role of constructor is whenever we initialize an object, the corresponding for the particular object, the default constructor will allocate the memory location for all the variables, and all the functions will be initialized. And for the variables, data members, the initial value will be assigned. And here we, instead of using the default constructor, we are making use of, we are writing our own user defined constructor. So the user defined constructor, we are defining what are all the operations we need to, the constructor has to perform when an object is initialized. Okay, within the constructor, what we are doing, we are assigning head equal to null. So it means there are no nodes in the head is assigned to null. It means the constructor is doing only one operation. It is initializing head equal to null. Okay, the head node is head variable is created. So within the list, we have a node called head. The address node is marked as null. It means it is null is a keyword. It means no nodes in the list. Then we are create code to insert an item into the front of the list. So the first function is insert in the front. So first we have to create the header node, that it means front node. So using this function, what we are doing, so the function is declared inside the class and defined outside the class. So while defining the member function outside the class, return type function class name, function name. So the class name is list, function name is insert front. Okay, in the insert front, what we are doing, we are creating a node star p. Okay, already we have a variable called node. So using the class node, we are initializing. So using the class node, we are using two classes. One class is node, another class is called a list. Using the class node, a node is initialized. Node star p, cout, enter an element to be inserted into the node, C in item. So a new node is created, and value to be stored in the node is received from the end user. And p is the new node created is called p. Using new node is a class. Dynamically a new node is created, and the address of the node p, okay, address of the node p points to data, that is the whatever value we are taking, in the data node we are storing the data, in the next node we are storing null, because the header initially only one node is created, that only one node in the list, so the address field is having the value null. So within the node, we have data field and next address field. Data field takes the value, address field takes the address as null. If head equal to null, already the head is assigned to null because there are no nodes in the list. Then make the newly created node p as the head. So initially nothing is there. First we are creating one node. That node is the first node. So we are making the first node as the header node, because already p is assigned as null. when we initialize the list. Now we are checking the condition. If head equal to null, then the newly created node P becomes the head. Else, it will be the second node. P points next become head. Head equal to P. Okay, the class will end in another 10 minutes. So inserted at the front of the linked list. So we are creating first node. That node becomes the header and it is insert and it is maintained in the first location, front of the list. The same way code to insert an item in the end of the list. We are creating a new node. That node we want to add it in the end of the list, void list, insert end, node P, node star P, enter an item to be inserted. We are reading the value using the class node. We are initializing a new node P equal to new node. The new node is created. P points data. The data field we are storing the value. Null the address field we are storing null. Then we are checking whether head is equal to null. Already head is assigned as null because only one node in the list. Now P points head, else node star T equal to head, while T points next not equal to null. If there are already some few nodes in the list, then the newly created node becomes tail node or the last node. Then T equal to T points next, T points next equal to P. In this case, we are already only one head node is there. The newly created node becomes the tail node. That new node is attached with the head. There is one head and one tail. The same way, if you want to add, already head is there, you want to add the new node in the front. In that case, we are checking where node star T, if head equal to null, because already there are two nodes in the program as per the program. Cout list is underflow. If there are no nodes and head points null, it means only head node is there, no more nodes. So the queue is what is that list is underflowing. If no nodes in the list, then it is underflow. If the node is having some nodes, then it will not underflow. If there are nodes in the linked list, then we can delete the elements. Else, item equal to, we are getting the new element, the element what we read from the keyboard, that will be assigned as head points data. So the newly node what we are getting, that we are going to add in the front. The front is the head node. We are getting the data, head points data, that is assigned to item. T equal to head equal to head points next. Cout the deleted successfully from the list. So here we are deleting the element from the front. So the head node data is assigned to item and head points T and head points next become head. So the data what we taken is assigned to head and that particular item delete T. So the data what we taken from the head is put into T, then delete T. Here delete is a built-in function. That delete built-in function is taken from std include std lib. And in the list, you want to delete the end element in the end of the list. In that case, we are creating node star t and star previous. So that points the previous node, address of the previous node. If head equal to null means the list is underflow. If head equal to null means only one node is there, the list is underflow. Else t equal to head. So the element content of head is assigned to t. Here we want to delete the last node. Delete last. The t points data is deleted successfully from the list. That is the head points next is marked as null. Then the last node is having the null address. That null address is transferred to the head and the last node is deleted. The same way we can delete a node before the particular position. So we'll get the position value, enter the position and take the header address and get the node count. So we are using a local variable int nc, number of node counts. Then we are calling the node count function. Through the node count function, we are getting the number of nodes in the linked list. If position is greater than the node count, there are 10 nodes in the linked list, and we want to delete the um, we want to delete an node 5. If there are some 6 nodes in the list and we want to delete the fifth node, then the node count will be 6 and the position we want to delete is 5. When the condition satisfies and the position is greater than or equal to 0, then if the both the conditions, this condition and what is this, and or and means address operator. Here we are using this or that, whether when the node count is less than the position or the position is less than or equal to 0, if any one condition is failed, and this will be executed. If both the conditions are false, then it will not be executed, because we are using or operator, this or that. Okay. So before deletion position, we are taking a node we want to delete. We are taking through the position. Then the content of the position is assigned to previous, and the address of the next is assigned to t and I plus plus. In that way, we are deleting. So we can delete a node in the linked list in the corresponding position or before the position. So the previous node before after the position, after the position means we are taking the previous address. And before deleting, we are checking whether the list is having numbers or not, data or not. If the list is having data, then only we can delete. If the list is empty, we cannot delete. If the list is so the condition to check whether the list is empty is underflow condition. If the list is having the particular number of elements, then we can delete the element in the particular list. Then we are displaying the elements in the list. If header is pointing null, if header points null, the list is underflow, no elements in the list. If the condition is true, the list is underflow. If the condition is false, then the list display all the elements. See out t points data, all the elements in the list is displayed. And code for counting the number of nodes. So how many nodes are there? We can count. So we are using a count called nc equal to 0. Okay, and we are incrementing the, we'll increment node count nc plus plus count, increment the node count and display the node count. The main program we are calling displaying the choices. While the condition is y, so choice is 1, enter your choice, choice is 1. We are displaying the node, insert, delete, all those things, insert, delete, before, after, all those things, and get the choice using switch case. Based on the choices, we are creating, initializing an object ll linked list. So through the linked list choice, we are calling the function. So any doubt in the singly linked list? Any doubt in the program singly linked list? The meeting will end in another 1 minute. I will upload the singly linked list program and the material. You go through it. If you have any doubt, ask me in the next class. Okay. I will take the attendance from the Zoom recordings. Any doubt?
No, ma'am.